You're listening to the Building HVAC Science Podcast with Bill Spohn. In this episode of the podcast, Bill talks with Nate Adams from Energy Smart Ohio about indoor air quality. Here's Bill.
Hello, and welcome back to the Building HVAC Science Podcast. Today I have with me Nate Adams, and we're going to talk about indoor air quality and humidity and HVAC systems. So, Nate, why don't you start off and give us a little bit of background on who you are and what you do?
Sure, Bill. I fell into this business years ago in outside sales for one of the fiberglass manufacturers. And then you might have heard of this little thing called a housing crash a couple years back, and my job evaporated with that. So I went into insulation contracting for existing homes, and the more I dug into it, the more I started learning building science, and the more frustrated I became that I couldn't solve client problems. So I ended up pivoting about 4 years ago now to becoming a consultant, and now basically I ride herd through a whole project. So I find out what clients want to fix in their house, then I help diagnose the house, build plans for what to do. We finalize the plans, go get bids, get the work done, and then test to make sure it all works. And then what we'll be talking about today is what we call continuous optimization, which is using data to make the house as good as it can be once the project is complete.
Why don't you give me your definition of building science?
Oh, you had to do that to me, didn't you?
Yeah, right.
It's such a broad thing. I would say it's the physics of how a house works. I've also seen it defined, and it's similar to what I do. It's managing the flows of heat, air, and moisture in a building.
So you're a moisture manager is what you are, in part.
In large parts. The more I learn, the more important it looks like it is.
Where did you get your background, or where did you learn about building science? How did this come about to you? How did you get trained on it? Where does this come from?
It all started when I met a fellow named Carl Balla not too long into my contracting career. And he walked me through a client house and said, so you caulk this and you seal this and here's what you do here and don't forget to do this. He kind of got me started and then said, you might consider getting some BPI training. So I went and got a BPI BA, a building analyst, and at the same time, I was actually one of the first classes certified for Energy Star 3, although I didn't actually follow through and become a HERS rater and get the Energy Star certificate, but I did pass the test. After that, I think because I'm working on this book of mine, there's not a lot of good 101 level stuff to bring people up to speed. You just have to go and figure it out. So I read a lot of stuff from Allison Bales, Green Building Advisor, the mighty Joe Stiebrick. You just have to read and then read some more and try and figure it out and get into fights and go through all kinds of things. But at first, for anybody who's a newbie learning building science, just go read the forums and just lurk. You don't have to comment. You don't have to say anything. Just lurk and learn.
Why don't you tell me a couple of those forums that are your favorites, and I could post them in the show notes so others can catch up.
That would be great. Anything by Joe Stiebrick. I start there. He's funny and he's accurate. And most importantly, if he's wrong, he'll admit it and then tell you why, which is really unusual. I really like most of Allison Bale's stuff. Obviously, this is Building Science Fight Club, which he coined. EnergyVanguard.com is a good place to go. Green Building Advisor can be excellent. The notes and the comments are oftentimes as good as the articles themselves. Those are really the primary ones where I mostly agree with them. Actually, no, there's one other one because this is an HVAC podcast. If you aren't on HVACtalk.com, get there.
Yeah, that is a good one. There are some building forums there. You threw out a couple acronyms there, and I want to make sure the audience understands those acronyms. So what does BPI mean, and what does BPI mean to you?
This will be some frankness then. BPI stands for Building Performance Institute. And they are basically the standards bearer for building science world. One of the big things that they do is they have standard testing protocol for combustion safety, basically dealing with the kind of water heater that I hate the most, which is a natural draft water heater. But one of the things that bothers me about them is I wish they had more of a business model behind what they do. They just expect you to take the training and then go figure it out. And I have watched so many people burn out, and I've been on the edge of burnout a number of times in the past 5-8 years. It would be nice if there was more of a business model to follow.
Actually, I was skimming my email this morning before we started this interview, this taping, and there's a webinar coming up on the 27th of September regarding staying in business as a BPI contractor, building performance contractor. So I think, Nate, somehow you've had some impact. They've listened to your words, or it's just a common theme that they realize in order to stay in business, you have to learn how to be in business. So that's great.
I'm happy to hear that. So I hope that it's helpful.
Let's get back around to humidity and indoor air quality in a healthy home. How much impact does humidity have on the indoor air quality in a healthy home?
I'm not sure that there is a more important piece. The more that I learned and the more that I watch readings from the various monitors that I have out in the field in my client homes. If humidity gets out of control, it drives VOCs or chemical pollutants up very quickly. And I've read a study, I forget exactly where it was now, but it talked about when humidity gets high, particles start to clump together. So you can end up with more PM 2.5. Some of the smaller stuff will clump. And it affects a lot of things. It can drive mold, obviously, and it's a big comfort thing. If you don't hold relative humidity down, you're going to get a lot more comfort complaints, where if you can hold humidity down, oftentimes clients will be happy with higher set points. So very consistently, I see clients go from 68, 70, maybe 72 degree air conditioning set points, and now I see set points between 74 and 80 post-project.
Interesting, because of the humidity control. I want to circle back around to something you mentioned. You said monitors in clients' homes. Explain that to me. What are you doing there?
Oh, sure. What was it? About 2.5 years ago now, I saw an article about a new indoor air quality monitor called Aware, AWAIR, coming out on the market. And it was this really beautiful looking little piece. It looks like a high-end alarm clock. And I got excited because now I could potentially begin to understand what was going on in client homes in real time. So until now, if I really wanted to understand whether my projects were a success or not, one of the best measures is waiting 12 months afterwards to see what the energy bills do. But that's a very slow feedback loop.
And it's also just a big bulk measurement. It doesn't really describe things in a micro detail, which can help you resolve things.
Precisely. So the more detail I can get of what's going on in a home from moment to moment, the more likely it is that we can figure a way out to resolve it. These hit the market about 1.5 years ago now, and I bought a bunch of them. I bought 3 or 4 and then borrowed a couple more from Linda Wigington and her Raucous project, and wrote an article in June of 2016 that was pretty beastly. It was like 3,700 words, walking through the pros and cons of all of the monitors that I had tried out. And the one that came to the top was Foobot, Foobot.
As everyone knows in the podcast, my company is TrueTech Tools. We actually sell the Foobot, but I'm sure Nate's going to be speaking very frankly about it. They're not endorsing this program or anything like that, but it is a great monitor. How many of these monitors, you have Foobots out there in clients' homes, as I understand?
Yes, I've got a little over 30.
Wow.
I should probably know the exact number, but I think it's 32, 34, somewhere in that range. The way to use these things is to put multiple monitors in client homes. You put one on each floor, or if they have one area that's a problem area, say an addition that doesn't heat or cool well, you want to put one in there. And then you can watch what the relationships are. The Foobot measures 4 things. It measures temperature, humidity, VOCs, also known as chemical pollutants, and PM 2.5, or particulate matter 2.5, although in truth, it's actually 2.5 to 4 is what that particular monitor measures. But by watching those 4 things across several different floors of a house, you can begin to see the relationships between things. So if the humidity gets high in one area, does it make it high in others? And yes, it does, of course, thanks to entropy. But the PM sometimes will spike in one area and then just barely nudge other parts. And other times you'll see the whole house will go crazy at the same time. Which
of those parameters would you say are the common ones you're looking at, or the ones where you feel like you can have some impact for the client? Of all those different parameters that it monitors, which ones do you focus on?
Humidity. Because if you can control the humidity, generally the other ones have more range. People can be more comfortable with wider ranges of what's going on, although that's not perfect to say by any means, because I don't want to leave chemical pollutant levels high in a client house. But if you can control humidity, you almost always control the VOCs, unless they're, say, cleaning with a strong chemical or something like that, where you can't do much with it. But in the case of HVAC systems, you can actually have tremendous control over all four of those. So for PM, what you want is a good media filter, say a MERV 11 or higher, with continuous fan, and that does a nice job on PM. And particularly if you've got a higher end piece of HVAC with an ECM motor, I typically run Carrier equipment or Bryant equipment, and they're pretty much always higher end stuff. So the ECM motors, I find if you're running low static pressures, the lowest I've seen so far was 26 watts for the fan, and the highest was 100. So running that all month is not very costly. That's generally $3 to $10 a month. So that tackles PM. And the VOCs, if you have decent dehumidification capabilities, you'll hold VOCs down. That's how it works. And then temperature and humidity, obviously, if you can't control that with your HVAC, what's wrong with you?
Okay, you mentioned HVAC control, and you're not an HVAC contractor, correct?
Exactly, yes.
So you must work with contractors. How do you find that relationship?
It was an interesting path, shall we say. There's a number of things that I'm looking for. I feel like I'm some 16-year-old teeny bopper talking about what I'm looking for, in a boyfriend or a girlfriend.
Search of.
Yes, but there's a number of things that I want. The most important thing to me is pricing structure. If you just double or triple the cost of the equipment, you're going to price yourself right out of somebody that I want to use, because I use high-end equipment. So I don't want something that I can get installed looking like it's thousands of dollars more expensive when I know that I can just go to a different contractor, their price is different, and get a really nice piece of equipment installed reasonably, because they're loading their labor rather than the materials, profit-wise. So pricing structure is really critical. Don't put crazy markups on the high-end equipment. The next thing is I need an owner who has some understanding of building science and doesn't look at me like I have three heads when they see my specification. Because my specs are getting tighter and tighter, because I learn every time, like, oh, I didn't spec that, and that's not quite what I want, but it's my fault because I didn't spec it. Then I like to have crews that are easy to work with and also don't think I have three heads when they read my specification. And then obviously just decent customer service.
Okay, so you must have developed those kind of relationships probably through trial and error, and you have some of those existing. Where do you do your work? Where's the primary amount of you worked on? Which part of the country?
I live outside Cleveland, so everything's Cleveland, Akron area in general. For whatever reason, nobody calls me from Youngstown, even though I'm not that far away.
When we talk about the area that you work in, do you feel that there are some trends or commonality in the area in terms of problems and housing designs, HVAC designs, those kind of things? Are you seeing any commonality, any kind of traits that are similar?
Static pressures are on the moon. I don't think I've seen a static pressure of any system that I've tested when I got there being under 0.5 inches water column.
Wow.
And then icicles are another really common thing that people are trying to solve, although these last two winters have been so mild, it hasn't been an issue.
Wait a minute. Icicle? How is that related to HVAC?
It's not 100%, but actually it's a good question to ask, because if you have icicles on a house, the house is very likely loose. So if you measure it with a blower door to test air leakage, it's likely going to be fairly high as far as leakage rate.
So when you use the term loose, what does that really mean to someone who understands how a wall is built, how a house is built?
You mean like building components?
Yeah.
So rim joists and basements are typically very leaky. Top plates of walls, either first or second story, are leaky. The band joist between the first and second floor can be leaky. There's usually a ton of holes in the attic that are leaky, and all of those are allowing heat, air, and moisture. Again, going back to building science definition, they're allowing heat, air, and moisture to get into and out of the house where they shouldn't be able to. And how that relates, I think you mentioned on the first episode, Dave Richardson calls the house the other side of the duct system.
Right, the connector.
Yep. So if you have a leaky house, you're very likely going to have issues with the duct system. You won't be able to heat and cool some rooms very well because they're going to require more heating and cooling per square foot than other areas. And particularly if you have oversized equipment that short cycles, which is what I always see. Actually, that's another trend. I'd say every HVAC system is 2 to 4 times larger than it needs to be when we run load calculations. So if you have a system that's short cycling, it's never going to run long enough to warm or cool those problematic rooms. By tightening parts of the house, you'll even out how many BTUs per square foot it takes to heat each room. And then by downsizing HVAC and putting in multiple stage HVAC, you can match what the house needs more often. And your odds of being able to keep those problematic rooms comfortable are much, much higher.
When you talk about the work that you've done, what have you encountered that surprised you? Something that you've learned along the road, along the path?
How many days do we have?
I can invite you back. If this goes well, I can invite you back.
The first one that comes to mind is the one that I came into your office and presented about. That was the deepest I've gone into addressing the HVAC issues in a home. It was a house that was built in 2006, which you would expect would be reasonably comfortable. But by measuring with Fubots, we found that the 2 problematic bedrooms that we were called about, even on a not that cold winter day, was running 11 degrees colder than the first floor. That's a huge split. You shouldn't ever see more than 2 to 3 degrees unless you want more than 2 to 3 degrees in one part of the house. So we tightened the house up. We actually got it spectacularly tight. I was really surprised how far we got it. For any energy geeks, it was a 1.6 ACH 50, if memory serves, maybe a 1.7. And then we put in a really nice HVAC system. So it was a modulating furnace with a 5-stage heat pump on top, and then a ventilating dehumidifier. So I set everything up, let it rip, and I'm like, oh, I should be good. I did everything by the book. Everything should work. No, the second floor was still 8 degrees warmer in the summer because the seasons had switched. And I was, frankly, scared because I'd done what I thought I needed to do to make it work. But that was when I got to measure actual duct flows. So I bought a little tool from you. It was an ABM 100 that attaches to my phone. And I started measuring the airflows. And then I choked off all of the supplies on the first floor. I closed every single one, the dampers. That looked like it worked. Looking with the Fubot, I'm like, oh, good. Now the second floor is actually running a few degrees cooler than the first. So I managed a 10-degree change in how the house operated. But then their son came home and closed his bedroom door at night, where they had been open previously, and I saw that same stinking spike again. It was now 6 or 7 degrees warmer than the house. So that was when I realized that the return side was not pulling well. So I went back up and I closed off most of the first floor returns to force it to pull from the second floor more, and that finally solved the problem. But I couldn't believe how much work it was to get those dumb bedrooms to operate at the same temperature, or actually it's cooling about 4 degrees more than the first floor, which is what they wanted.
So you were really balancing the supply and return airflow in each of the rooms?
Yes.
Were you balancing by pressure, or balancing by airflow, or balancing by result?
Yes.
The temperature and humidity. Well, you said yes. I asked you 3 things.
Yes.
Which one was it? Come on.
All 3 of them.
Oh, really? Wow.
So by flows, I could do the supplies because there was enough flow to measure. The returns were so big that I couldn't get a measurement out of them. So I used the manometer for my blower door and turned the air handler on and then closed the door on each room and saw what the pressure difference was. Was it pressurizing or depressurizing that room when the air handler was on? And then I made adjustments and checked again. And so I had a pretty good idea that I had it by the time I was done with those adjustments. But then I still had the Fubot sitting there, and I got to watch what happened over time. And it was fixed.
So the feedback that the client would give you, it was more about the comfort level, perhaps?
Yep. Ultimately, what really matters, as we all know, is the client happy or not? But they're going to give you anecdotal evidence So if they're happy, it's good. But I joke that a lot of it is like going to the mechanic and saying, when I turn left, it goes thumpa, thumpa, thumpa. And he asks you mean chunka, chunka, chunka. And then you just both stare at each other like idiots and like, we'll take it out on the road and try and duplicate it. So the anecdotal feedback from clients is oftentimes not particularly useful. So being able to see the temperature, humidity, in this case, chemicals and PM over time really gives you a better idea of what's going on in the house, so you can watch it over seasons and look for trends.
So going back around to these monitors that are in people's homes, you have them there long after you've done the work, or do you keep them there for a period of time? How does this arrangement work?
Good question. I'm making it up as I go. So I place them when I do the energy audit. It's typically a couple weeks before I come back with the recommendations. So I place them there for 2, 3, 4 weeks so that I have pre-project data. That's how I know that it was running 11 degrees colder. And then during or just after the project, I place them again, because obviously not everybody goes through with the project, or they oftentimes take a while before they execute. So once the project execution happens, I place them again. I'll leave them for a good long while. I'm trying to leave them for a good year so that I can see how the house performs through 4 seasons.
This doesn't sound like the typical kind of thing you could do on an everyday basis. But again, that's your business model. Your company's name is Energy Smart Home Performance. You're about solving home performance issues?
Yes. The problem houses usually find me. When somebody's already made 2, 3, 4 runs at a problem and haven't solved it, I'm the big guy.
Let's go back around to some basic things. And how do you define home performance?
I'll probably default to the 4 tenets, which is making homes that are comfortable, healthy, long-lasting, and efficient.
The long-lasting aspect, that's something that some people call durability. So does HVAC tie into durability? Is it just the HVAC system itself, or can there be things that a system does or does not do to increase the durability of the house?
And that's why we're talking about indoor air quality and humidity today.
Funny how that works.
If you don't control the humidity inside a house, sooner or later you're going to have a problem. So if you run dew points that are too high and then the basement gets cold, which is pretty typical in most homes, typical house that I see, you go down into the basement in the summer and it's an ice box because the ducts are leaky or the supply didn't get closed. So the area of the house that does not require cooling is getting cooling. But that's bad because now the surface temperatures down there are cold. And it's not that hard if you aren't managing humidity very well to get dew points to the 55, 60, maybe even 65 degree range inside the house. And in the basement, it's not hard to have surfaces that are colder than that. So you're going to get condensation, which can lead to mold, and that can exacerbate asthma, and it can lead to rotting. There's all kinds of things that can happen if humidity is not well controlled in a house. And the HVAC is ultimately what has to do that job. You need a tight house to start with, but then if the HVAC is not managing humidity, you're in trouble.
The phrase I've heard is build it tight and ventilate right.
Correct.
When you talk about building tight homes, you need to have proper ventilation. How do you ascertain what's the right amount of ventilation? What kind of systems you provide? What kind of measurements do you take?
So I'll start with a measurement that's easiest. I don't know if it's 100% correct because you had talked to me about that a little while ago, but I use what's the name of the tool now? It's a flow hood, but it's one specifically for measuring bathroom fans. You know the name, Bill.
An exhaust fan flow meter?
Yes, thank you. So I use that to get an idea of where the flow rates on the fresh air systems are. Now, one of the curses of my work is oftentimes I don't have the budget for fresh air. So oftentimes we'll just do a return scuttle with a damper on it that we can close when it gets too hot or too cold. So we're not pulling in, say, 10 degree air or 85, 90 degree air with high humidity.
And Scuttle is actually a brand name of a product?
Yes, although I'm using it more in the way of a Kleenex as a tissue in this case. Mostly what I'm looking for is being able to turn it on and off at different temperatures so that I'm not pulling super hot or super cold air in that I then have to treat or that the clients could feel when it's too hot or too cold coming out of the vents.
Can you just simply describe what that is? Is it just a dampered vent that brings in outdoor air?
Yep. Instead of, say, a 4-inch bath fan exhaust, we'll use a 6-inch and then pull out the flapper, and presto, you have an intake. And then you connect that to the return duct system, oftentimes a little bit down the line, And then you have to be sure to insulate that line, or it's very likely going to get condensation on it in the winter.
Because of the indoor humidity level versus the cold, dry outdoor air that's moving through the system.
Correct. Yeah. Winter dew points inside houses are usually somewhere between 25 and 40. So if it's a 40-degree dew point inside, all you need is air that's under 40 degrees, and you're going to get condensation.
Let me ask you kind of a challenging question for people who are listening in the audience. Do homes need humidifiers?
Yes.
When do homes need humidifiers?
Leaky homes might need them for 2 or 3 months out of the year in the winter. So remember, I'm from a cold climate. So if you're from Florida, ignore this. You don't need a humidifier ever. But even on the West Coast in a dry climate, it might be a nice idea to have a humidifier. Now, the big thing to keep in mind with humidifiers, though, is 2 things. If the house is not tight, be very, very careful, because I have seen a lot of mold in attics caused by humidifiers being run too high, and then that warm, moist air sneaks into the attic, condenses on the roof deck, and turns into mold. So you have to be very careful with them. The second big caveat is if you have anyone who is mold sensitive or asthmatic, it might not be a good idea to do a central humidifier. You might want to stick to room humidifiers, because you are going to be putting moisture into probably some less than ideal things inside the duct system.
What times of the year do you find are worst for generating these complaints that draw you in to consult?
Been about equal the last couple of years between winter and summer, but it's the extremes. Occasionally I'll get a stinky house complaint from spring and fall because you have high humidity levels, but there's no cooling load, so the air conditioner's not running, and houses just get gross, which is, again, why dehumidification, having that capability in a house all year, is very important from everything that I'm learning. But in the wintertime, you get a bonus room over a garage that's running 15, 20, even 30 degrees colder than inside the house I've seen.
And there.
Yeah, I think I'm betting most HVAC practitioners have.
In a northern climate, yeah.
Yes, in a northern climate. And you could solve that with a mini split, but that is dealing with the symptom rather than the root cause, which is oftentimes air leakage and lack of insulation is usually what's behind that, mixed with those rooms seem to consistently get underducted. They really should have 3 supplies or 2 supplies, and they only have 1. That doesn't help, and it's the long run, too.
Yeah, the long run and the twists and turns getting out there, which affects the static pressure and the delivery of the air, sure.
Precisely. Again, though, if you right-size the HVAC and you make it multiple stage, that room's going to get much longer runs of heat or cool into it, and that oftentimes helps a great deal right there. I can't recommend right-sizing HVAC enough. And it's shocking, but we find that in houses that are relatively tight, you can undersize by 50 to 60% from manual J and still handle design temperature.
You talk about air leakage. You're talking about the air leakage for the home, the building shell itself, or shell leakage, envelope leakage, it's also called. What kind of tool do you use to measure air leakage? How can you determine what that is and if it's good or if it's bad?
Blower door, maybe. That is the tool. For a really tight house, I've seen some people use duct blasters for it, but I don't see tight houses.
I know you're working on a book called the Home Performance Book, and it's directed or targeted at homeowners or consumers to explain how their homes really work and how to solve their problems and who they can call and what can be done to solve problems. How would you describe a blower door to a homeowner or a consumer?
It's basically a big fan that we put in your front door. So we put this big shroud in that covers most of the door, and then it has a little round hole in it that you put the fan in. And it blows a lot of air either in or out of the house, depending on how you set it up. Generally, I'm blowing air out. And then you can depressurize the house. So you get the equivalent effect of 15 or 20 mile an hour wind blowing on all sides of your house at the same time. Once you run that for a couple of minutes, you can pull out your infrared camera, and if it's a little bit warm or a little bit cold outside, see that warm or cold air leaking into the house any place that it's coming in. It's a really wonderful diagnostic tool. The second thing that you can do with a blower door, though, which I actually find more important, is what's called Zodal Diagnostics, which sounds all fancy, but it's not. All you're doing is you take the gauge off of the blower door with it running, and you throw the tube underneath the door, close the door, and you can find out how much that room leaks to the outdoors. And that's a huge chunk of what helps target where the work on that house goes.
It helps you determine where the leakage points are. How important is air leakage to solving the problems that you encounter? And I mean air leakage in terms of both duct leakage and in shell or building leakage. How many times does that show up in the problems that you encounter, the clients call you in on?
When it comes to air leakage into the house, approximately 110% of the time. Give or take 10%. Air leakage is pretty much always the root cause of what I'm trying to fix. Very seldom do I find a house that's tight enough that I end up aiming for HVAC first. I have what I call the 5 priorities of home performance, and the first one is to air seal the house. The second one is to air seal the house more. The third one is to keep air sealing. The fourth one is finally insulation, make sure that you have enough. And the fifth one is installing the right HVAC. Air leakage, it just causes all kinds of things. Going back to humidity, if the house is leaky, if the humidity levels outside are substantially higher than they are inside, that humidity is going to push right through all those gaps and into the house. It doesn't require stack effects, which we can touch on. But as long as the levels outside are higher, that humidity is going to sneak inside the house. So if you're having difficulty managing humidity, unless you tighten the house or install a huge dehumidifier, you're never going to win that war. Does that help?
That helps a lot. In terms of quantifying air leakage, I've had some personal experience and I've also done some reading. But what's your experience with how big of a hole is too much or how small of a hole is too little to worry about?
Depends where it is. If it's in the attic or the basement, you want to go for pretty much anything you can get. In the walls, it doesn't matter as much. And I'll touch on stack effect. So what the stack effect is, a house acts like a smokestack in winter. The cold air comes in through leaks at the bottom of the house and then rises anywhere that it can through the middle of the house and then out into the attic or through the top of the house in whatever way it can. So your high pressure is at the bottom of the house where it's coming in and at the top of the house where it's coming out. The middle of the house doesn't really matter. So even if you have leaky windows, unless it's a windy day, it doesn't really matter. But the holes that you want to seal are top and bottom.
There's a company out there called Dr. Energy Saver, and I know that they have a process which they call ABC. First, they take care of the attic, then the basement, and then the conditioned space. That's their priority order in terms of addressing energy leakage issues, ABC, and it's very clever the way that worked out.
It is wonderful, although they actually have a AA as well, which is leaky ductwork in the attic, which makes total sense because you have pressurized, heated, or cooled air being leaked into the attic. So it's a double or triple whammy.
What I call expensive air. You've created expensive air and then you're wasting it.
Yes. And I like that term, by the way. Expensive air is a good way to put it.
Good. Hey, go ahead and use it, please.
I'll be stealing it. Yes. You know what R&D really stands for, right?
No.
Rip off and duplicate.
Okay. We're going to do a lot of that in this podcast. We're going to do a lot of ripping off and duplicate. So you've given me a lot of great ideas. I think you provide a lot of terrific content for our listeners. If people want to reach out to you, dialogue with you, learn a little bit more, what's the best way to do that?
That'll be email. And my email is nate@energysmartohio.com.
I did mention a little bit earlier a book that you're writing. Why don't you spend a couple minutes and describe what that book is, why you're doing it, and how it's constructed, how it's going to roll out? Oh, great.
So actually, this has just been evolving somewhat. So I just started a new website. It'll be up this week, actually. It's called NateTheHouseWhisperer.com. It was because I found that trying to do it on my essentially contracting website was muddying the waters. But about half of the book will be free, and about half of it is going to be for pay. Each chapter is meant to stand alone. And what it solves is a number of problems. So most of the books that I've seen on building science or home performance, they're either too nitty-gritty, where they dive straight into here's how you do stuff, or they're too heavy on the why, and they're, say, 30,000-foot level. We need to reduce energy usage in homes by 40%. And it's like, well, that's great, but how do you actually do that? So what I'm trying to do here is connect the how and the why in a consumer-friendly way. Another way that I look at it is a lot of the books that I've seen on this are like reading a math book that has the first 7 chapters ripped out of it. So you deep into the weeds and you're just like, what's a blower door? I need some basic definitions while I get started. And you also have to have some understanding of how the house works physics-wise before you can even begin to understand what's important and what's not. So this is very much meant to be helpful to consumers. And for HVAC practitioners, I'm also working out ways to use it as a lead generation or an email capture mechanism on your website.
I think with the way things are going with consumers in terms of them being able to get at their fingertips a lot of information, a lot of research, and some of them may be of questionable value or erroneous or misleading, that you're trying to put an element of truth out there. When you say the first part of this book is free, is any of it available now? And how would somebody get it or get involved with you? Is it best to contact you through the email?
Yeah, if you're a practitioner and you want to work something out, email me, please. But very shortly, I will have it up on natethehousewhisperer.com. And you'll be able to download the individual chapters or buy the book as it is right now, which is 6 chapters worth. It's some 200 pages or so. And the chapters that are complete are Home Performance 101, which was really hard to write. HVAC's Basics chapter, which walks you through the things that you really want an HVAC system to be able to do by comparing it to your car. HVAC Sizing, which is the first one that's done that I charge for. There's a lot of nitty-gritty in it, and I charge for nitty-gritty. And then there's Insulation Types chapter, which can be really helpful as consumers are trying to figure out what kind of insulation do I use. And then there's 2 fairly simple chapters, which are choosing and installing the right bath fan, and then figuring out which light bulb to buy, because the new ones are pretty confusing.
We've covered a lot of ground here. I think we'll see what some of the reaction is from our listeners, see what some of the feedback we get. Hopefully some people get in touch with you. And we can probably come back around and dig a little bit deeper on another edition of the podcast if you're interested.
I would be happy to, because, we barely scratched the surface.
I think, we did. It was quite broad and sweeping. Any kind of parting thoughts you'd like to leave us with today? Any little nuggets of information? Again, we're talking to a hybrid audience here with this podcast, people in building science and in HVAC. What kind of nuggets of information, 1 or 2, you'd like to leave us with today?
The critical thing that I'm pushing for is to move away from combustion. And part of it is getting off fossil fuels, but a lot of it is actually that the comfort you can provide for your consumers is much better. Heat pumps obviously come in much smaller sizes. So we have been putting heat pumps into old homes. So we pulled 4 gas meters off of existing homes, and all of them are pre-1920 in Cleveland. This is not the warmest climate in the world. And the feedback from those clients on the comfort levels in their houses are nothing short of spectacular, because they are multiple stage and right sized. And since you can't hardly buy furnaces that go down as low as multiple stage or modulating heat pump, I can't recommend using heat pumps enough.
Well, I think we'll wrap up right here, and we really appreciate you having you on the show today. Again, this is Nate Adams of Energy Smart Home Performance is your company name. Energy Smart Ohio is your website name, your domain name. We'll be looking forward to coming back and hearing you again, perhaps when the book launches and you have a little bit more to talk about that.
Wonderful.
Thanks a lot, Nate. Really a pleasure having you here today.
Thank you, Bill.
Thanks for listening to another episode of Building HVAC Science. I'm Brian Orr. I'm actually the founder of the Blue Collar Roots Network, which is the network that the Building HVAC Science podcast is a part of. And we have a lot of different podcasts that represent blue collar trades, and a lot right now in the HVAC industry. So if this is the first podcast you're hearing on Blue Collar Roots, I would suggest that you go over and listen to the HVAC School podcast. HVAC Shop Talk is another great podcast. Tool Pros is a podcast with Brent Ridley and Billy Noth, all about tools and primarily HVACR tools. And then also we have the Service Business Mastery podcast, which is all about best practices for running a service business. Again, relates to the HVACR industry. So thank you for listening to this. If you wouldn't mind subscribing to this podcast, the best way to do that is to do it on the podcast app on your phone. If you have an iPhone, if you have an Android phone, you can download the Stitcher app and subscribe there, or you can do it right on the Google Play Store. So there's a couple different ways you can do it with Android. But the biggest thing that I need to communicate is just thankfulness that you're listening. Thank you that you are looking looking to improve your career, because that's really what the Blue Collar Roots Network is all about. It's about bringing together that brotherhood and sisterhood of people who work in this industry, working to improve the notoriety and the prominence of the blue collar trades. So thank you, and we will talk to you next time on Building HVAC Science with Bill Spohn.